So I don't have any slides because this is all code, except for my 10 slides. This talk is about some of the low-level memory operations in LabVIEW, where you basically I'm worried about large arrays, large strings, large objects, and avoiding copying them unnecessarily. And to do that, I got to talk first about the Desktop Execution Trace Toolkit. How many people have used this? All right, how many people use it a lot? Use it a lot, okay. All right. I'm going to talk about how using it for rapid debugging and how I think you can use it more effectively. And I'm going to talk about something I'm going to call bracketing using probes. And then if we have time, I'm going to talk a bit about how we can improve the Desktop Execution Toolkit to make it more usable using a new viewer that's written in LabVIEW. Second slide, see if it works. So a big problem I have with the Desktop Execution Trace Toolkit, I can show it by running. I'm going to run a DQMH project, the continuous measurement and logging. Give me a sec. This is the trace toolkit, or the viewer of the trace toolkit. And if I run, and this is continuous measurement and logging, so I'll log some data and I'll stop, and I'll just stop everything. And I run for like 2 seconds of data. Let's see what I got. And I got 4,700 trace events. So if I'm looking through this, there's some color, but it's quite difficult to say, ask a question, what's going on, and find something. It's very difficult to find anything. So let's just switch over. First I'm going to get a smaller thing to look into memory. Here's sorry. Oops. So what I got here is a little test VI, and I'm just going to test a bunch of simple code things. So the first one, for example, is just I've got a giant string in a cluster, and I want to put it in a different cluster. And this is the kind of operation you do when you're kind of reformatting, going from one cluster to another. So if I run this one, let's see if there's a draw to it. Yeah. If I run this one, it's of course many fewer events, but I'm not actually. It's really hard to see which of these memory allocations is the one I'm interested in. Yeah. Where are these allocations happening? So to get more information, what I'm doing is going to call bracketing. So in LabVIEW, I'm going to make a custom probe. I already have them, but I'm going to make one to show you. So new probe. I thought I'd do this because I always call it something stupid. So if you look at the probe, there's this control, which is the data, and it says, do not delete. Delete that. Right, okay. So now you have a dataless probe. I don't know if everyone knows you can do this. This is a dataless probe that will go on any wire. Of course, you don't get the data, it's dataless, but you can put it anywhere you want. And what I'm going to do in here, I'm going to put a trace event, a user's custom trace event. Let's see, trace event. I think I've got to create a constant. GDevCon. And then save. Right, I think it should appear. And you can put it on any wire, so I'm going to put one here at one end. And I'm going to put one on the other end. And now I'm going to clear. So now what I've done is I've bracketed the code I'm interested in with 2 probes that give nice yellow lines. And the key is to ignore everything outside the lines. You can actually do this in your real project and ignore the thousands of events outside, quickly narrow down to just what you're interested in. So this is the important thing of using the toolkit, is you have to be able to ignore 99.9% of everything. It's kind of like what you were talking about. You have to find the interesting thing quick. So now we can easily see that we actually have a memory allocation in the little bit of code that I'm interested in, which was just taking it out of a cluster and putting it in another cluster. So now, and we can even put a probe quickly to debug, add another probe right in the middle between the 2 operations. And we can run it again. Now we can see they've got 3 probes, and we can see that the memory allocation happens after the first, before the second. And that's the unbundle. So for some reason, LabVIEW has decided that it should copy this large string rather than just use it, and that's what we don't want. So now I'm going to show you some of these things and how you can avoid the copies. I don't like the code you have to write because this is simple. I'd rather just write simple code and it'd be memory efficient. So this is a rewrite using the two key things that you mostly use, which is the in-place element structure and sometimes swap values. Swap values tells the compiler, I want you to not do any copies, just swap the pointers of these two data types. And so what I've done here is I've taken the cluster and I've taken an empty cluster with an empty string in it, and I swapped between the two. So I'm telling the compiler, do it this way. Just clear this. And if I do that, there's no memory allocation between the two probes. So that's sort of the basic idea of testing some code, identifying errors, and coming up with better code that actually avoids the copies. And also show to use the tool, I want to very quickly find the key thing that I'm interested in. I want a simple question, immediately find the answer to my question, throw away all these trace data, and do something different. And the problem is that these are all surprises to me. I would not have thought that the compiler would make a copy there. Because to me, it's obvious that you don't need to copy this large string, but the compiler does, and you have to tell it more explicitly what to do. So here's another one, even simpler, just add to an array. So I've got an array of 3 strings, giant strings, and I'm adding a 4th giant string. And I would not expect this to make a copy because I'm just adding it, right? There's no branch. But if I run this, you can look, there's down there, that's the memory copy. Now there's 4 strings involved, the 3 coming in and the 1. It doesn't copy the 3, but it copies the 1. So how can you avoid that? Well, you have to swap. What I've done here is I add an empty string to the array. That copies the empty string, but I don't care about that. And then I swap it into the last element of the array. Right, and if you do that, let me show you. That eliminates the copy. There's no copies between the others. Now, there's a problem, and the problem is, I should make that bigger, this is ugly. I don't want to have to write like this. But it's worth it. So I don't advise people to do this except for, I use this a lot in my reuse libraries. So I have a messenger library that does a lot of array stuff. And I went through and optimized it with these kinds of techniques to get much better performance. Because sometimes I send large data around, and I want to strictly avoid any unnecessary copies. And 2, I've used this in JSON text, because again, that has large strings. And you again, although you normally, JSON isn't very big, I want it to be usable for large amounts of information.
You put it in a DIF?
Oh, Jesus Christ. Okay. You are smart. Yes, you can put it in a VIM. So this is a VIM I wrote for Messenger Library. And it basically does the same. It basically it goes through the 0 iteration for loop. That produces an empty thing of whatever you've put in. So this will work for objects or strings, I think maybe arrays. And then you add that makes a copy of the empty thing, and then you swap into the last element. And so this will work for any kind of object or string, and we'll avoid a copy. Let's do that, hang on. And again, that's no copy. But again, that's ugly, but it is encapsulated in a Vim. So that actually is a thing that I actually did to make a few Vims I could drop in instead of all this ugly code. Okay. Let's see. Got to keep an eye, okay. So this is a no one. This is, I'm taking an array of things, and over a loop, I'm changing the data. Here I'm putting in a cluster. And there, because the array was 3, I get 3 copies. Actually, when you do the indexing on the output, it makes making the copy, I think, because it's basically adding. And for the same reason that the add does, it makes copies, and that's really disastrous. And that can be fixed. Again, you pre-allocate, and I don't need swap values this time, but I can just I can just move the things across, and the compiler this time is happy not to use swap values. But I still have to pre-allocate and do this kind of ugly code to make it not make these copies. Does that work? You trust me? Yeah. So I got rid of copies, and that's 3 copies. So that's a very important thing to do, particularly if you have a very large array. That's why you had to use that quite a lot in Messenger Library, because Messenger Library has a lot of arrays of objects. I'm going to skip this just because, well, this is just basically, if you take an index of an array, take out one element, even though you're not using the rest of the array, it'll make a copy. And to fix that, again, you just have to do it in the in-place element structure, which is telling the compiler, you're certain the compiler, actually, swap out, I want you to use this value for sure. And then often, so this is reorder of an array, where again, you're taking the index and doing this. I can't remember what this result is, so let's do that. If I run that one, yeah, it copies each element, each array, as it goes through. So you're just reordering. And when you reorder, you don't want to copy. And the whole point of reordering things is to not make a new copy, just change them. And how would you do that? Again, it gets ugly. Oops. Again, you pre-allocate an array of the size you want, and then you take them out and you swap from one element to one array to the other. But again, this is ugly. I don't like doing this. And to really show the ugliness. So this is, I took an OpenG function, which is like a sort function, and it looks like this. If you run this one, you end up with, so many, it goes off screen, it's six copies. So that can be really expensive if you're using big data. And I'll show you quickly how you would go through. So this is an example of what if you were in your actual code, an actual function is complicated, you know there's a problem. Now you want to go through and identify where the problem is. So you'd add your custom probes. I'll add it there, I'll add it there. And then with the probes, you can quite, so you can actually quickly see that find between the probes, there's 3 at 1 and 3 at the end. And you can quickly figure out from the probes that it's from the first bit of code, which is just again, it's all the places where you take something and you sort of reorganize where it is. You can put it into a cluster or take it out of a cluster. These are where the copies are. And this, you can trust me, makes no copies. But it looks like that. It's so ugly. And it takes a while to do because you've got to like try it and then run it and do some probes and try it again and gradually get to the point where the compiler will not make copies. But as I said, it's very, very ugly. I only recommend it for reuse code or in an application code where you know you're going to deal with big data and you really have to pay attention to the path of the big data. Okay, now a question for the audience about variants. So here's code, and all I've done is I've taken a giant array, a giant string, I've put it in a variant, and I've converted back to a string. How many copies? 3. None. So when I say variants are actually pretty good. Variants, well, you put something in a variant, take it out, it doesn't make any, unless you're taking it out in a different form, like if you put in a double array and take it out as a single array, of course it's got to convert. But if you put things in a variant and take them out, it doesn't involve any copying. The only exception, and this has been fixed, so this is good news, When you have a variant input and you give a non-variant to it, so it implicitly converts to a variant, that makes a copy, but has been fixed as of 2023. So I'm running in 2021 here. If I run this, it'll make a copy right there. And that's a copy just before the sub-BI call. So I do not know why it does that, because if you change it to a variant yourself explicitly, it won't make a copy in any LabVIEW version. How much time do I have left? Okay. So I think I have time. I'm going to talk about substrings. So substrings are particularly important when I'm trying to optimize JSON text, because it's all about strings. A substring is a special data type where rather than having the data, it points to an actual string and says, the data is this string starting from here for this long. So it's a tiny data type, but it points to another string. And if I run this, which is just take a slice, it takes the giant string and it drops the first 100 bytes and gives you a substring of the rest. So it's still a giant amount of data. If I run that, there's no copy, and that's good, right? Because the substring doesn't involve actually making a copy. But it's easy to lose the benefit of this. So here's an example of code that I might have commonly. So if there's no error, give me a substring of the incoming string. If there is an error, then I want nothing, right? Because the standard error behavior is to return nothing. So if there's no error, I just have return nothing. If you run this code, not with error, no error, if you run this code with no error, you get a copy. And the reason is I think that there's two code paths. One is a substring of the initial string. The other is a different string. And the compiler can't do that, can't do the either or, so it must convert the substring into a string so it can provide a string as the output. And the way to get around that is that, again, on no error, I'm giving you the giant substring. On error, I'm giving you a zero-length substring. It's a zero-length substring, but it's a substring of the original string. So both paths return substring of original string. So the compiler says, that's fine, I'll return a substring. So if you run this one, now there's no copy. So this actually, that actually was kind of useful. So there's lots of places where that happens, where you get yes or no, error, no error, or two cases. One returns a substring and one doesn't. And by changing how that works, I managed to avoid quite a lot of copies. So another thing quickly is that, I won't show it, but if you have a substring coming out of a sub-VI, it becomes a string. Unless you inline it. So if you inline the sub-VI, if you inline sub-VI, it's happy, substrings can come out. If you don't have an inline sub-VI, then the substring becomes a string. So that's another benefit of inlining. And that's it for that. So there's one other, actually let me just close some of this code. One other memory issue that is particularly problematic to me, and that's for user events. So I use user events a lot in Messenger Library as my main pass messages around method. So I care about the memory efficiency of user events. So here what I'm doing is I'm creating a large string, I'm sending it by a user event, I've registered for it, and I'm taking it out, putting it in a cluster, because often I get the data, I put it in something. It's not just going to sit there. And I'm going to, again, use my custom probes. The fire. Sorry, it takes a while to do this. I'm just putting custom probes at each step because I want to see where memory copies happen. So I put them after the actual fire the user event, receive the user event, and then leave the event structure. So the answer, which is strange, so the first memory allocation is just, I'm just creating the array, so we expect that. Then we have a yellow bracket probe. Then we have an allocation when we fire the user event, so it's making a copy. That's fine, I mean, I kind of expect that. I would actually prefer to just take it, but then when we receive it, we get 2 copies. And this is the weird thing about user events. You get a copy when you send it, and you get 2 copies when you receive it. One of the copies, down there that is memory free, is thrown away when you leave the event structure. So this is very strange behavior. What I would prefer is, obviously there can be 0 to n people registered. I would like 0 to n copies. Or actually, I'd prefer 0 to n minus 1, because you can take the original data type I'm sending, you can take. But really, there's 2n plus 1 copies, 2 times the number of people registered for it. And that is pretty deadly for if you're going to send, 100 megabytes or something, because you're going to make 3 copies. The only way I've discovered to get around that, and again, ugly, is to put it in a DVR. So these are short-lived DVRs where you take your data, put it in a DVR, send the DVR, and then just immediately release the DVR to get the data. Putting in a DVR and taking it out doesn't make any copies either, so that's really good, and it's very fast. But it has a problem that you need someone to be listening, because otherwise, if there's no one's listening, you're just massive memory leak. And if there's multiple people listening, they can't all get it. Just one person can get it, and they'll fight over it. So that's sort of all the things I have to say about the different ways of eliminating copies for these low-level operations. Again, it's worth doing for reuse code. So if you have some kind of package that you use a lot. It's also worth doing if your program is really using big data. It's worth going through the main path and doing it. It's not worth doing it because it's all so ugly and expensive to do for day-to-day code. Now I'm going to shift slightly. That was the desktop execution trace toolkit. The thing you see, that's not really the tool. The tool itself is actually in LabVIEW. LabVIEW has the ability to pipe out data about itself called the desktop. There's a series of properties that you can just connect with VI server and say, start shoveling traces to me, and you can pull out the trace information yourself. This thing you see, the actual viewer, that's I guess .NET viewer written long ago. But you can write your own viewer in LabVIEW and add new features. So where is it? Review. So here's one that I've written in LabVIEW, and this just takes the information. We'll do the DQMH one again very quickly. It traces in and actually puts it in an SQLite database. And doing that allows me to add new filter functionality easy. Let's see. So I do what I did at the start. No, it's not working. Why is it not working? Hang on. Don't suddenly not work. It's beta. Come on, I've done something wrong. What have I done? Try it again, do you think? Yeah, as I said, this is come on. Tried this morning.
This is because your DETT is stolen.
Ah! Is that it? Oh yeah, that's another thing. It's not designed for more than one person at once. It's not designed for more than one person at once to be listening to it. I forgot all about that. Yeah, there we go. All right. So the thing before, run for a little bit, stop. And we'll just shut everything down. Now, this is the same thing where I got a big list of stuff. And again, it's probably got 4,000, 5,000 things. But, so the first feature I added, because is a search box. So I know that I'm interested in the simulated data that this is using. And I know that it says simulated, if I can spell it right. I can jump down immediately to the bits where I'm simulating things. Other things I added is, one, I let it indent by the call depth. And also, if you've selected something, it highlights in blue everything in the same call. So the blue stuff or anything in the same call as the event I've selected. The bold black is the call chain. All of the light gray are things that are occurring in the different module. So this is a DQMH program. It's got different modules. I'm only interested in the acquisition module at the moment. So everything that's in a different thing is in light gray. And that allows me to quickly ignore, because you see that things are actually happening in parallel. And that makes it really hard to do traces if all the traces are interleave. But by doing this, I can see that the acquisition module, I can see its traces and ignore the logging module. Features. So this is very new, but because I've done it in LabVIEW, I can add features. And I'd like to be able to do things and to support things like DQMH. So it's easy to focus in on, I'm only interested in this module, or I'm only interested in this sub-VI. I want to avoid the need to go in and put probes by allowing you to quickly identify what you want and get to it quickly, because the whole problem with the current DETT is that it's so long to try to find the information you want. And I want to be able to go very, very quickly down to it. I even have a feature around here which is like a back button. So if you move around, it goes back to where you were before. Because of the DET, you find something painfully, and then you go look at something else, and then you try to find where you were before, and you painfully have to find it again. So a back button actually helps. So you can go look something else, go backwards. Anyway, so that's a new thing. I'm hoping to develop it when I get some time. What's the event manager, sorry?
Oh, in LabVIEW we have the event manager.
Oh, okay, those things you get.
It's basically an API, and you can also get those events.
You do see the events. So one thing I did is, in the original DET, you get the user events and the events happening, but they're not highlighted. And I highlight them in green so they stand out. I don't know if you can see that here. Oh, it probably doesn't have any user events, but.
So I have a question, if it's okay.
Yeah.
So I was wondering, what's the performance hit to the CPU? Because if I do a lot of the things you do, but there's most of the time I have to do it often, and then I see a huge performance hit, so I always have to balance the RAM savage with the CPU hit. So have you tried that, or checked how much CPU usage, how it increases that?
I haven't. I kind of got on the assumption that if I'm not making a new memory allocation, I'm not copying, that's got to be better performance.
Yeah, but some of the, from my tests, some of the improvements to the memory allocation has a larger CPU hit than I would imagine.
Okay, well, there's different things. I think these ones that I showed is just either make a copy or don't.
Okay, no,
So
that's
I mean,
just...
I think performance will go high up. One thing I added here is I'm trying to improve the timing, because a lot of time in the old one, you want to see how long it took between two different events, because you're trying to figure out performance. And I've tried to make it by putting a column that's the DT, the time from the previous event. So you can go through the column of DT and look for big numbers, and that tells you something interesting.
So on the ideas exchange, this is more of a comment for the group. I'm going to make an idea, which is that since all this data is already available and published, that it gets fed directly into Nigel, so that Nigel can actually let you know where the memory allocations are happening and the time difference between two marked allocations. So NI R&D, would that interest you guys in having a look at it and see if we can get this information into Nigel and have it tell us what our code is doing? And if this group wants to, could they kudos that idea on the Ideas Exchange?
Yeah, it would need to be post-processing, but we can take a look at it.
Would it be a logical thing to put into Nigel as in to help us get insight about our own code as opposed to just, right now it's telling us what the front panel does, so what the block diagram does?
Yeah, I mean, Nigel will be expanding with every release, so we'll have to see. We can run some tests and see how the LLM does, and if it does a good job, then yeah.
Thank you. Guys, look out for the Ideas Exchange post if you guys want to comment on it.
Do you open source it?
Yeah, I posted it somewhere on NI. But it's easy to do it yourself because it's just a bunch of VI server calls and it just pipes the data to you.
Recreating this is like a lot of work.
Yeah.
So if this is in a Git repo, we can just, as a community,
It is in a Git repo somewhere. So yeah, it's a bit buggy at the moment.
Yeah, thank you very much. Did you check also the LabVIEW feature of show buffer allocations and how accurate it is in showing where memory allocations happen?
Oh, you mean the tool that would show buffer allocations? I did not actually. I mean, I have limited space, so I really focus on. This tells you exactly what the information is. The problem is, it shows things like the substring. That's an allocation. It is because the substring is, I don't know, 10 bytes long, telling you stuff. There is an allocation, but I only care about big allocations.
That's what I meant with the accuracy.
Yeah.
Thanks.
Yeah.
I had a quite basic question on the DETT. If we want to use it on an application that runs a bit longer, so like, I don't know, a minute in or so into the application run, it would capture the whole time. And does that affect performance?
Well, I mean, you're not running this while your code is actually running in use, right? This is a debug tool. It will, I guess, assume it adds some overhead. I'm not sure how much.
Okay.
But what I do is, again, when I do this, I make big arrays, 100 megabytes, 10 meg, 100 megabytes, so they actually get a big effect. And the fact that the tool itself will, of course, slow it down a bit isn't relevant.
Okay, thank you.
Yeah.
So first of all, that's really a really cool tool. The one feature that we have in a log viewer is that we can bookmark single lines, so that we can. So you already have the call chain of where you are, but we can like take one line and bookmark and say okay, and it even highlights those bookmarks so that we can jump back to the bookmarks.
Yeah. So one idea is be able to say, like, this is what I'm interested in. Maybe this sub BI is what I'm interested in.
Yeah.
And so it remembers, and when you run again, you can highlight it, jump direct. You have a button that jumps directly to it.
Sweet.
Yeah. I'd even like to put things like have it understand active framework, DQMH, messenger library, and be able to tell the different modules running, so it can like maybe put them in different colors, so it's more obvious to you which is which. So here you would have the acquisition and the logging module be in different colors.
Very cool. Thanks a lot.
Okay, thanks, James.